launching 6, okay, cores are over.
Yes.
Okay, even the RAM is there, cores are over. Okay, but if I want to give a container, I should give core plus RAM both together. But I don't have cores. I means resource manager. Okay, so I am resource manager now. Okay, so application master is coming and asking. Okay, so think that, okay, this is Venkata, this is Bharani. Okay, so Bharani is the application master. So Bharani is coming and asking me, hey, sir, Venkat sir, okay, I want, okay, 10 containers in this machine. I want 10 containers in this machine, 10 here, 10 here. Give me 10, 10, 10, 10, total 40. Now it is the responsibility of mine to give 10 containers here, 10 here, 10 here, 10 here to Bharani. Okay, now, okay, yes, this is my responsibility, but do I have chance to launch, okay, 10 containers at a time?
No.
I don't have. Okay, so what I will tell Bharani, okay, hey Bharani, you're asking 10, but okay, with the available resources, I can give you only 6. Okay, you take first 6. Okay, the remaining 4, let it be in waiting state. I will give you after completion of this one. Yes or no? Okay, it is the same case even here also, right? Okay, Bharani, you are asking, okay, for 10 here, but okay, as per this requirement, okay, this available resources, okay, as per this YAN allocation, I can give you only 6. Yes or no?
Yes.
It is the same case here also. Okay, I can give you 6. It is the same case here also. I can give 6. Okay, I can give 6 here also. Here also 6. Here also 6. Will you agree with me? It means, okay, in the first attempt, okay, the Bharani is asking 40, but okay, Venkata has given only how much? The first iteration?
24.
24. 24. Yes or no? Yes or no, guys?
Yes, sir.
Yep.
Okay, Bharani is asking 40, but okay, Venkata has given only 24. Because, okay, that is the maximum capacity, okay, Venkata can give.
Yes.
Will you agree with me? Okay, so now, so all the 24 containers are started. Okay, so and these containers will start reporting to application master. Okay, start reporting to Ganesh. Okay, application master here. Okay, so now what application master will do? Application master will tell, hey, mapper 1, you process block 1, mapper 2, process block 2, mapper 3, process block 3, mapper 4, process block 4 here. Okay, mapper 5, process block 5, mapper 6, process block 6. Like this, okay. Like this, okay. It will allocate the work for each and every mapper. Okay, so now what they will do, all 24 mappers will start parallelly. Yes or no? Yes or no?
Yes, sir.
All 24 mappers will start parallelly. Okay, so now as and when, okay, let's say, okay, first mapper is completed their work, and okay, first mapper will store the output into OS disk. Yes or no?
Yes, sir.
Yes.
Okay,
Yes.
into OS disk. Okay, into OS disk. After that, okay, so first mapper will go and ask, okay, application master, okay, application master, my work is done. Please release me. Okay, so it means, okay, so it will be released. Released. Released means, okay, I'll put it like green. Can I put it like green? So like this, okay, all mappers, okay, will run parallelly. Okay, once their work is completed, they all get released. Okay, when they all get released, okay, what are the available resources with each node manager? Now, when they all are released, okay, they will go back to pool. Now, how many resources node manager is having? Node manager 1 is having.
6.
Huh?
6 cores.
6 cores. Okay. So now, okay, resources are available here now. Correct or not? Now
Yes.
RM will say, okay, hey, application master, you asked me for 40, right? Okay, I gave you only 24. Now I will give you next set of 14 mappers. Okay. Here, okay, this is the mapper here. This is the second setup. Okay. Now in this scenario, your job is running in 2 iterations. Why it is running in 2 iterations? Because, okay, we don't have enough resources. Yes or no? We don't have either cores or RAM. That is the reason it is going in 2 iterations.
Sir, it will be used for the first set also, right?
Sorry?
Already free, right? For the,
Huh?
they can use the first set also, right? They
What do you
already
mean first
released.
set, sir?
In,
What do you mean first set? Sir, parallelly all 24 are completed, sir.
okay.
Okay? When they completed, all these are released.
Yeah, they are free now.
This is the situation, right? Okay. Once the work is completed, what will happen? Tell me.
The resources
The
will be
consolidated report saved into the
Okay,
local
it means
disk.
okay, all are released here. Okay, in the first iteration, all are released. When all are released, okay, what are the available resources in the pool?
Again, 6 cores and 26
6
GB.
cores, 26 GB. 6 cores, 26, 6 cores, 26, 6 cores, 26. Okay, but now okay, application master needs 16 more containers, correct?
Yes.
Mapper
Yes.
containers.
Yeah.
So in the second iteration, it will give the 16 more this one. Okay, in the second iteration, it will take the first iteration. Okay, in the second iteration, it will process.
Sir Venkat sir, that first iteration output can be stored in local file system
Yes,
after
yes, sir.
waiting.
Okay. Yes, sir. Okay. All see first iteration. How many outputs will come here? So if you see after completion of first iteration, okay, inside local file system we have 6 mapper outputs. Correct?
Yes. Yes, 6 map output each.
Here also 6 mapper outputs. Here also 6 mapper outputs. Here also 6 mapper outputs. Correct?
Okay.
Okay. So now, okay, it started doing the next iteration. Okay, this is the next iteration. Okay, it allocated the resources. Now, okay, after completion of these mappers, okay, what will happen? So again, okay, these 4 mappers will write the output to OS. These 4 mappers will write the output to this OS. These 4 mappers will write the output to this OS. These 4 mappers will write the output to this OS. Yes or no? Once this is also completed, okay, it means okay. So here, in how many batches okay, my work is okay? Okay, see, application master is asking for 40, but okay, available is only 24. It has given 24. Okay, so with the first 24, okay, it has started the work or not? Or is it
Yes.
waiting for all 40?
no, sir. It will start the work.
No, no. Sir.
It will start the work, sir. Even if you have one, if you get one container, okay, work will start. Understand? Sir, okay, in real time, okay, so you will be submitting jobs on terabytes of data. Sir, no? Sir, no? Okay.
Yes, sir.
Let's say one terabyte. Okay. How many blocks you will have? 8,120, 126 blocks, 8196 blocks. TB equal to 8196 blocks. Okay. If you are running a job in 20 TB of data, okay. Just imagine, sir, how many blocks you will have? 20 TB of data. 20 into 8192. 163, 840. Okay. So 1,63,840. Okay. So 20 TB means how many blocks you will have? 20 TB of data means. Okay. It means okay. To process this data, you require okay 8192 mappers. Sir, map containers. Sir, no. To process 20 TB of data, how many mapper containers you require? 163, 840 map containers you require. Yes or no?
Yes, sir.
Yes or no, sir? It means okay. How many containers we require here? If I want to process 20 TB of data, I require okay 1,63,840 map containers I require. Okay. Do you think that okay Do you think in one attempt itself I'll get like a 840 163,840 containers? Will I get to at one stretch itself?
No, not possible.
Huh? Not possible, right? In that scenario, what it will do?
Batch wise.
Batch wise. Okay. So with existing resources, can I process this much data or not? But it will go like batch wise. Yes or no?
Yes, sir.
Okay. Sir, okay. What is the difference between traditional processing and okay? Suppose okay, if you say traditional processing, okay, okay. If I want to process okay 20 TB of data, what is the RAM I require? What is the required container I require? I need. What is the required container size? If I want to process 20 TB of data, how much RAM you require? How many cores you require in traditional way? Huh? So 20 TB plus logic plus 10% of your buffer, 20% buffer. It means okay, nearly 25 TB RAM you require. Understand? 25 TB RAM, okay, plus one core. This is what okay, it will work. Understood, sir? If I go in the traditional way, if I want to process this data in a traditional way, how much container? What is the container size I want? So only one container. Okay, half size this much. Understood? But okay, in case of okay parallel processing,
Sir,
parallel processing.
sir,
Tell me, sir. I'm listening.
yeah. If that means in traditional processor only one container will be released, that itself will act like application manager as well as
Sir,
map.
okay, in traditional processing, you don't have application master and all, right?
Yes, yes. Okay. So altogether is going to be one container.
One container. That's it.
Okay. Thank you.
Okay. So if you have okay 25 TB data, you need 25 TB container. Will you have 25 TB RAM?
No, no.
No, right?
Right.
Okay. But okay, let us take this scenario. Okay. So in the parallel processing, okay, when I say parallel processing, you will have multiple servers. Yes or no? Okay. So okay, let's say you have server one. Okay. In that case, you have five servers. In each server, okay, how many you can launch? Okay, let's say, okay, so okay, 6 cores plus 26 GB RAM. This is the capacity of each server. Okay, 6 cores, 20 GB. Okay, what is the overall capacity, sir? Total? What is the total capacity? 30 cores plus 130 GB RAM. Sir, no. The total capacity, sir. I have 5 servers. Each server is having this capacity. Okay. So now I have total 30 cores, 130 GB RAM. Okay. So now if I have okay, if I want okay, if I have this one, if I have 20 TB of data, so what I will do, okay, this 20 TB of data will be in the form of okay, these many blocks. Okay. So in the iteration one, okay. How many, okay, with this capacity, how many mappers I can launch? This is the capacity. So definitely, okay, so first the application master will start, right?
24
Application master will start.
containers only we can launch.
2 GB plus 1 core, okay? After taking this one, okay, what is the left out here? Okay, used, okay? Overall, okay, overall free, how much? So in this 30 cores, okay, one application.
29.
28.
29, no, 1
29 cores.
okay, 29 cores plus okay,
128
8
GB.
GB RAM. Okay. So with this, okay, in the iteration one, how many containers I can launch? Total how many containers I require?
29. Okay. Total
Okay.
these many.
Okay, so but in one iteration, how many I can launch?
29 containers.
29 only we can launch, yes.
So iteration 1, so I can launch 29 containers. Yes or no? Okay. So if I launch 29 containers, how much resources will be used here? 29 cores and 29 GB. Yes or no?
Yes.
Okay. So first iteration is done. Okay. Now in the second iteration, okay, I will use this one. I will work on my 29 blocks and I will release it. Again, okay, the same 29 I can use for second iteration, right?
Yes.
Okay. In the same way, go for third iteration. Same 29 containers. Okay. Like this, okay, divided by 29. Okay. Like this, okay, how many iterations I will go? 5650 iterations I will go.
Sir, each iteration application master will contact to name, no?
So why each iteration? Only first time only it will contact, right? For each iteration it will contact RM.
Okay, RM. Okay. Okay.
Understood?
Hmm.
Sir, okay, see, already application master has this information, right?
Yes, yes, got it. The
So
same
now, okay,
batch will start, right?
same
Same
blocks,
application.
right?
Yeah, same path.
Okay, so how many iterations it will go?
650.
Okay, so now all together how much is coming? All together, how many cores? Okay, so it means, okay, it means 163 840 cores plus 163 840 GB of RAM overall utilization. Yes or no? Yes or no, sir? For each block, okay.
దీనికి వస్తుంది సౌండ్ వస్తుంది అదే చెయ్యి కూడా వస్తుంది నాకు వస్తుంది రాకపోతే నాకే వస్తుంది వాళ్ళకి remove device.
Only you have to resubmit your query again. Okay. The failed query you cannot do anything, right?
Yes.
Here also same thing.
Okay.
Understood? If any job is failed, you cannot do anything. You cannot rerun. Okay. You cannot do anything with that job. Only thing is that you have to rerun the job with a different configuration. Got it?
But we couldn't change YAN configuration, sir.
Sir, okay. I will tell you.
That means that resources are not available on that case.
What, sir?
In YAN configuration, we have to change. I don't have any.
No, why you need to change an YAN configuration? You can pass this size of this. Size of application master, size of mapper, size of the.
Okay, but application master is launched by only resource manager. That's why.
So what? But see, I told you right. I told you right yesterday. Okay, see. End of the day, so who will decide the size of application master, size of mapper, size of reducer? Who will decide?
User.
Lakshmi will decide. Understood?
RM will decide only maximum size of container, right? With the name node manager. No, node manager.
What RM decide? Okay, we'll see later. Okay, the size of mapper, size of reducer, size of application master will be purely decided by user who is submitting the job.
Yeah.
Understood?
Yes, sir.
So, sir, here if we are dealing with the huge data, then we also need to make sure there is enough space in the local node operating system.
Yes. That is the
Is there any
cluster planning we will occupy we will give 20% space, free space for OS.
OS?
Yes.
Okay.
Understood?
And there will be a specific separate location for this for these output files, right? Or it can also be
separate location.
Mapper outputs.
Every mapper will have separate location.
Got it. Thanks. Yeah. Is there any specific? I understand it's definitely going to be the number of resources available in the cluster, but is there any predefined rule, like okay, only these kind of sizes or only this much load can be ran using the YAN job?
We will talk about that, sir. Okay. Sir, in this scenario, suppose what are the total available resources here, sir? What is the available resources in each server? What are the available resources in each server? Server 1, server 2.
For YAN, it's 6 cores and
26, right? Okay. Suppose Lakshmi submitted a job. Okay. When submitted the job, Lakshmi told that my application master size should be P course plus okay 30 GB RAM. Okay, my mapper size should be 1 core, okay, 30 GB RAM. Okay, okay, 1 core 20 GB RAM. Okay, my reducer size is 1 core, okay, 50 GB RAM. Okay, if this is the number, okay, Lakshmi given in the config in the command submitting the job. Okay, now tell me where application master will launch, in which server application master will launch.
It probably going to fail because no server, individual server have 30 GB of memory.
So what RM will do to launch application master, it will check in each and every node manager who is having how much. Okay, anyone is having 30 GB. The maximum yarn allocation is only 26 GB, but you are asking 30 GB. Is it possible to launch application master?
No, sir.
Now RM will throw error saying that, hey guys, okay, for me the allocated capacity is only 26 GB. Okay, but you are asking 30 GB container. So I am sorry, I cannot give you 30 GB containers. So your job will fail at the time of application master starting itself. Understood? Understood, sir?
Yes, sir.
Okay. Suppose, okay, let's say you have given, okay, my application master size is, okay, 25 GB. Okay, will it work now? Application master can be launched?
Yes.
Okay, so now application master will launch. Okay, then, okay, so mappers, can we launch mapper?
Yes, sir. Mapper also.
Only, how many mappers I can launch at a time?
3.
What?
Only one.
Only one mapper. Why?
One map. That RAM is not available.
So after launching one mapper, okay, the left hand resources are, okay, 5 cores and 6 GB RAM.
Yes.
To launch second mapper, I require, okay, 1 core and 20 GB. But I have 5 cores, but, okay, no GB, no RAM. Yes or no?
Yes.
That means, okay, in iteration 1, okay, only one. In iteration 1, per server 1 container only. Yes or no?
Yeah.
Okay. So now, okay, application master is fine. Okay, will mappers run? Yes, mappers also will run.
Yes.
Now, what about reducer?
Oh,
What is the size of reducer you are asking?
50 GB.
50 GB RAM.
Okay. Do you have any machine, okay, which supports 50 GB containers?
No, sir.
No
No.
support. Okay. Now your job will fail at the reducer.
Yes.
Our reducer, no output.
No reducer. Okay, your job will fail. Now RM will say when it reaches, okay, reducer stage, okay, RM will say, hey, I'm sorry guys, okay, you are asking me 50 GB container. I don't have any server with 50 GB capacity. I'm sorry. And okay, and fail the job.
Sir, application master will launch equal size in mappers if n number of mappers are launched at that time. Is there
Sorry,
any tool for?
sorry.
If the mappers are launched n number, that sizes are same, or is there any?
Sir, okay, mapper size is same. Okay, even if you launch 1 mapper, 10 mappers, 100 mappers, okay, all mapper size will be same.
Okay.
You will not have mapper 1, okay, 21 GB, mapper 2, 22 GB, mapper 3, 24 GB, like that.
No.
Okay. So if you are launching 1,63,380 mappers, okay, the size of each mapper will be same.
Okay. Thank you, sir. Reducer also, sir. Reducer also same
Also, if
scenario?
you are using multiple reducers, okay, you will tell only one size. All reducers will follow that size one.
Okay. Fine.
Got it?
Got it, sir.
Yeah. Any other questions?
Sir, in real time, like basically when all the mappers are working in parallel,
Okay.
there might be a chance each mapper will complete their job in different times, right?
So what is the problem?
Will you still wait for the remaining mappers
No. Okay, see.
to move to the next iteration?
Mapper 1 is completed here. Mapper 1 is completed. It will go to application master and tell, hey, my work is completed. Application master will release the mapper 1. Okay?
Okay.
Now mapper 1 is available in the pool. Yes or no?
Yes.
Immediately, block 7 will be given to mapper 1.
Okay, yeah, that's what my question is.
It will not wait, sir.
Yeah. Okay.
Understand?
Okay.
You should visualize.
Sir, if n number of developers can submit n number of jobs, only one application master will handle that n number of jobs.
No, sir. Okay. Every job will have one application master. Sir, if you have 10 projects in your company, 10 projects will have only one team leader or 10 team leaders?
10.
Huh?
Okay. 10, sir. 10.
Sir, one question regarding this OS disk size. So OS disk size also we need a little more, because if there is a like there can be a possibility that where we require more, because output can be of bigger size, yes.
Yes, sir.
And everything need to be stored in that OS disk. So it should be free space should also be considered while
Of course, yes.
while
You should have more. You should have more free space, sir.
Okay, sir. Okay.
So, guys, okay. I hope okay, you got clarity. Okay, how? Okay. Okay. Now tell me. Okay. Even okay, if I have 30 cores and 130 GB RAM, can I process 20 TB data or not here in Hadoop?
Yes, sir, we can.
See here, okay. Suppose in this scenario, if I have in the traditional processing, I have a laptop with 30 cores and 130 GB RAM. Can I process 20 TB of data there in the laptop?
No. Take.
No. Okay. So in traditional processing, okay, it is not possible. Okay, but in distributed processing, yes, it is possible. Understand?
Yes, sir.
Sir, can you give me one real life example for traditional processing and distributed processing?
Yes, sir, please.
Can you give me one example? That's what I'm saying. Huh? So traditional processing will say that so this is so this is traditional. Okay. So this is the pizza.
Go to the Tirupati, sir.
No.
Yeah, generally the people travel to Tirupati.
Pizza. Okay,
One burner, sir. In one burner we can cook one thing. Yes. Nowadays there are in kitchens there are multiple burners available, so
Good,
we
sir.
can
Good.
cook.
Okay.
Yeah.
Let's think about food for some time. Okay. So in traditional way, you have one pizza. Okay. What traditional way is saying that you eat entire pizza at a time. Got it?
Got it.
Okay. Understand? Maybe if you are a Superman, you can eat entire pizza at a time. Correct or not? What distributed processing is saying? Okay. So you cut your pizza into pieces. Okay. Eat each slice at a time. So here also you are the same person, sir. Okay. Here also, okay. So person one. Okay. Let us take here also Lakshmi. Okay. Here also Lakshmi. Okay. Same Lakshmi, if she follow traditional way, she cannot eat this pizza. Correct or not? Huh?
Yes.
Okay. But the same Lakshmi, if she follow the distributed way, can she eat this pizza? Yes or no, sir?
Yes, sir.
So in traditional method, there is no block mechanism, right, sir?
Sorry?
In traditional methods, there is no block mechanism.
Of course, yes. The entire pizza has to. You should eat entire pizza at a time. So if you want to eat that entire pizza, you should have that much big mouth. Yes or no? Huh? But in distributed processing, what you are saying, let it be a big pizza. Okay, let it be 4 pieces or 6 pieces or 8 pieces. Okay, don't worry. You eat piece by piece. Got it?
Sir, when we say distribution means it equal in size?
Huh? Distribution means piece by piece.
Okay. Size.
Store piece by piece. Okay. Process piece by piece.
Size, sir. The piece size is equal.
Yes, piece size is equal.
It must be equal.
Must be equal. So let it be, sir. Okay, sir. Okay, if you buy a pizza, is there any guarantee that always all the pieces will be of same size?
No.
Okay. So here, okay, when you have here when you have 20 TB of data, it should process 20 TB of data. Okay. In 1 JVM. Okay. So the same 20 TB of data, okay, you process, you do it in small pieces and process in 163, 840 JVM. You understood the difference?
Understand.
Sir, even if you have 5 cores, even if you have 20 GB data, 20 GB RAM, you can process 20 GB of data in distributed process.
But batch by batch only.
Batch by batch. I will go by batch by batch. Yes or no? And again, distributed processing, So when you say distributed processing, you will have distributed storage also, right?
Yes, sir.
If you don't have distributed storage, then distributed processing will not work.
Yeah, in HD.
That is the reason, So to use distributed processing, we are telling that your data should be inside SDFS. Okay. If you want
SDFS concept, no processing layer.
No distributed processing concept.
Together
Understood.
it can work.
Yeah, wherever it is.
Okay.
Clear?
Yes.
Okay. So fine, guys. Okay. Yes, you got an idea. What is this one? Okay, now we'll see what is application master. Okay, one application master for each job or application. What does it mean? If 10 people submit 10 jobs, okay, how many application masters you will have?
10 application masters.
10 application masters. Okay, so then kind of a later container in the application. So application master is the later container in the application. Okay, and it is responsible for analyzing the application requirements and creating job terms in XML file. Okay, contains properties used in job submission execution. Okay, so guys, we will do one thing. Okay, before going to this, okay, shall we see the practicals? Whatever we understood till now, shall we see the same thing in the practical? Huh?
Yes, sir.
Okay, sir.
Sir, one small doubt.
Yes, sir.
Sir, can we correlate this with the JVM concept here for application master?
Container, so container is the next level of JVM, sir. Understand?
Okay.
But when we give the container size, basically all on process will be the container size, right? Every container size will be defined. Where is the configuration, sir? Where it will be defined?
I will show you, sir. I will show right now. Okay, so I know that you people are getting a lot of doubts on the configuration part. Okay, I will tell you right now. Okay. Okay. So now, what we will do? Let us start yarn. Let us start yarn. Okay. So now, so far, what and all we have here, guys? So far, if you see our this one, this is our practice, right? Sir, no. Is it the case now, guys? Zookeepers are running. 3 zookeepers, 3 general nodes here, 2 jet KFCs. Okay. No, we created 4 jet KFCs, right? 4 name nodes. 3 data nodes, and the last one is edge node. This is what we did right now. Will you agree with me, guys? This is the storage layer. Yes or no? Huh?
Yes, sir.
You say yes or no. Otherwise, okay. I will go in my speed in that case. Okay. Fine, I will not expect your answer then. If you have any doubts, you ask me. Okay. So I have 3 zookeepers here, 3 general nodes here, and 4 ZKFCs, and 4 name nodes, and 3 data nodes. The last one is edge node. Okay. So now, okay, to start yarn. Okay, before you start yarn, please make sure your storage layer services are stopped. Okay, started. Okay. Anyway, these are all started now. Okay. Now in S3 N1, okay, open
So we need to
local.cmc.
make sure it should be stopped or
Start,
in
sir.
running
Start.
state itself.
Start.
Okay, got it.
It should be started. Okay. So now here, okay, what I'm telling, what I'm adding here in the class configuration file, I'm telling that okay, RM, where resource manager I'm going to start. My idea is to start resource manager on 181. Okay. But where I'm telling okay, node managers here. I'm not telling anywhere, right? But anyway, see, wherever I have data nodes, I will use the same group for node managers also, right? Huh? Yes or no?
Yes, sir.
Okay. So here, okay, my idea is to start RM here. RM. Okay. Again, RM is a master service here. My idea is to start RM here. Okay. And okay, where to start? Okay, this one. Okay. So here, okay, let's type in RM. Date. Yes, it is giving one machine. And now open on-site XML. Open on-site XML. Okay. Again, this is the configuration file. Okay. Just copy paste all these things.
Sir, we don't have backup for RM.
Sir, even okay, in name nodes also we started with one name node, right?
What is JHS in previous command, Venkat? JHS.
Where, sir?
Sorry.
Class type G RM, sir.
No, RM is there, but JHS also mentioned as group.
Okay, JHS. I'll talk about this, sir. I missed means okay.
Sir, sorry.
I'll talk about that. Okay. Okay. Now I'm adding these properties here.
Sir, you are telling something about RM.
Sir, okay. Even okay, when I start the storage layer, the first day itself, okay, I've shown you 4 name nodes. Or okay, we started with one name node.
One name.
One name.
Started with one name.
One. Okay.
Here also in the processing layer also let us start with one RM.
Then we will see high availability.
Okay.
High availability. Okay.
Okay.
Yeah. So we are starting with only one RM. Okay. And I've given the properties here. Okay. What are the properties I've given here? Now, okay. So what is the resource manager here? Who is the resource manager here? S3 and 1. Okay. S3. All these three are related to resource. All 4 properties are related to S3 or resource manager only. Okay. So resource manager recovery enabled equal to true. Okay. What do you mean of recovery enabled? If the resource manager is down, okay, so when you start, okay, if there's anything to recover, okay, if you set this property to recover, it will recover automatically. Okay. So after that, okay, I've given some properties. Okay, I will talk about these properties later. Okay. So then, okay, so this is important thing. Okay. So now, okay, what properties I'm giving here? What properties I'm giving?
16 cores.
Okay. Why I'm giving 16 cores here, guys?
Virtual.
Do you see the properties, guys?
Virtual course.
Okay.
We are giving.
This is the property I'm giving. Okay. How many cores I'm giving? Wherever I'm starting node manager. So these are the node manager properties. Okay. These are the node manager properties. Okay. Now, what is the size of this node manager here, guys? What is the normally? What is the actual size? What is the size of VM I have taken? What is the size of VM I have taken? What is the size of
10
S3 and
GB.
3?
10 GB.
10 GB, 3 cores, correct?
Yes, sir.
So 10 GB plus 3 cores. Okay. 3 cores plus 10 GB RAM. This is what, okay, capacity of each machine. So now, this is the capacity of each machine. Will you agree with me, sir?
Yes, sir.
Okay. So now, okay, in this, okay, so how much, okay, we need to give for OS? 20%. Okay. What is 20% here? 1 plus 2 GB RAM is for OS. Eternal. Eternal is. Okay. But do you mention, okay, do you mention this anywhere? Understood? No need to mention in Hadoop, this property. Okay. So what you will do, you will say, okay, yarn allocation you will tell. Okay, yarn allocation what you will tell, okay, you will tell, okay, yarn allocation is 2 cores plus 8 GB RAM is the yarn allocation. Okay, this is all okay. So need to mention. XML file. Understood, sir? Okay. See, you will mention only this thing, but you will not mention this anywhere. Okay. But okay, automatically Yan will understand that. Okay. Okay. So you leave this one. Okay. So now normally, okay, how much is required for OS here, guys? 20% for OS, right? Okay. So leave those 20% resources and okay, put in the AN configuration that okay, so my AN capacity is 2 cores to 8 GB, 2 cores 8 GB, 2 cores 8 GB. This is what we are telling in the YAN side. Understood? In this scenario, what YAN will do? YAN will take only maximum this resource. YAN will think, okay, so these are the resources given to me to launch my containers from this machine. Understood? Or any questions?
So, sir, each machine will have different XML file, or it will be.
Sir, okay, you will have same XML file copied to all the nodes, right?
Yes, sir, correct. So, how it will understand that this particular node? Okay, it will be same for all. Okay, got it.
You got it. So this you need to mention. Okay, so what OS will think? Okay, since we have given this one for Yan, okay, the rest of the resources for me. Okay, OS will think automatically. Understood? So the OS properties you will not give anywhere, but Yan properties you will give in XML, Yan site XML. Understood, guys? So it means okay, you are telling, okay, or your Hadoop is telling your machine that okay, you are telling Hadoop, okay, or you are telling your Yan, okay, hey, in this machine, you take max only this much. Don't touch remaining resources. Those resources are for OS. Understood?
Sir, YARN resources means that for both node manager and resource manager, sir?
Sir, resources means, okay, only data node resources are the resources. Your mappers, reducers are launching in resource manager machine?
No, node manager.
Only node manager.
Okay, thank you.
Got it?
Yes,
okay.
Sir.
So, this information, okay, so here, okay, you are saying, okay, so you are clearly mentioning in the configuration for saying that, okay, this is the maximum capacity you can use in this machine. This is the maximum capacity you can use in this machine. This is the maximum capacity you can use in this machine. Okay?
Using the thumb rule, sir, here, the
20%, 80% is the thumb rule, sir. Yes.
Okay.
Okay. So normally you will take 80% here. 20%, okay, you will reserve for OS. Okay. So now, okay. So where, okay, what is the property to talk about this one? What is the property to talk about this one? This is the property which we'll talk about.
So, sir, what 16 represent? Like how you calculate it to be 16, sir?
Wait, sir. So these two properties, okay, what you need to do for these two properties, what you need to do, you need to, okay, you need to tell, okay, so maximum course 2 cores, okay, maximum RAM 8 GB. This is what, okay, you need to tell. Understood? In MB, right? Okay, okay, so let's say 8 in MB you need to give. Okay, MB, if I convert 8 GB to MB, 819 to MB. Will you agree with me? Yes or no?
Yes, sir.
So these are the two properties which talks about. Okay, what is the maximum I can take from here? What is the maximum I can take from here? What is the maximum I can take from here? Understood? Huh? Now? Understood, sir, these two properties.
Yes, sir.
Okay. So now, okay, now what next? Okay. Now the container, sir. This is the, what is this one? This is
But
the
sir, we
answer.
mentioned this allocation
Sir,
MB as
sir.
1024, yes? Okay.
Sir, please don't look at that Excel sheet, that Word document, okay? I will explain that, what I did there.
Okay, sir.
Okay, na? Okay? So this is the property I put here. Okay, so this is fine now. Okay. Now, the next property, okay. Now, this is the resources. Okay. In these resources only, I should launch the containers, correct or not?
Yes.
Okay. Now, if I don't control the container size, okay, suppose, okay, one person come and say, I want, okay, a container of, okay, okay, I want, okay, what to say? So now, Lakshmi is saying that, okay, Lakshmi is telling that, okay, hey, I want my application master of, okay, 2 cores plus 8 GB RAM. Then what will happen? Okay, the memory will be taken for entire resources, okay, will go like one container. Okay, you can launch only application master here. Okay, after launching application master, will you have any free resources here?
No, sir.
Huh?
No.
After launching application master, do you have any free resources here?
No.
No, sir.
If application master is 2 cores 8 GB RAM, okay, if application master is running here, okay, 2 cores plus 8 GB RAM, okay, all the resources are over. Sir, no. I cannot launch, okay, only if I launch application master, that's it. I cannot launch any more containers. Okay, all resources are over here. Sir, no. So it means, okay, is it a good way or bad way? Or is it a good thing or bad thing?
Bad thing.
Bad thing.
Why bad thing?
Because it's going to take full memory space.
Okay, so it is a bad thing because, okay, it is using entire resources here. Okay, that is the reason. Can I control? So it means even Lakshmi says that, okay, 2 cores 8 GB RAM. Okay, no, RM should not give that much. Okay, now you are controlling. What you are controlling here? Okay, you are telling that, okay, there are high chances that people, okay, without knowing how to set the size of containers, they will give big size of containers waste. See, now I have a BLK001. Okay, I have BLK001 of 128 MB, sir. Okay, but Lakshmi has given mapper size as, okay, mapper size as, okay, 1 core plus 8 GB RAM. Okay, then what will happen? Tell me. It means, okay, this one block 1 will run inside 1 core 8 GB RAM. Yes or no?
Yes.
So to process 128 MB data, do I really require 8 GB RAM?
No.
No, right? Is she wasting unnecessarily or not resources?
Yes.
She is unnecessarily wasting. Okay, but who will control? Who will tell her? Will you sit, okay, as an admin, will you go and sit next to Lakshmi and say, hey Lakshmi, what are you doing? Okay, or what is the application master size you are giving? What is the mapper size you are giving? What is the reducer size you are giving? Will you go and sit and ask? Like this Lakshmis, okay, so there will be hundreds of Lakshmis in the project. Yes or no?
Yes, sir.
Okay, we cannot go sit next to them and ask, okay, or continuously watch, okay, what is the size of mapper she is giving, what is the size of reducer she is giving and all. Okay, but okay, she is giving a number which is okay unnecessary number. Yes or no? So for this 128 MB, if she give, okay, if she, what is the best one? If you give 1 GB, 1 core 1 GB, this is okay. Okay, this is super. Okay, this is okay. Luxury.
Default size.
Default size. Okay, but can you okay, this also?
No, sir. Only one
Can
GB
give
will
this
be.
also. Yes.
MB
We
we will
can
not
give
use.
because 128 MB only. Yes. So
100 MB, right?
500
Okay, so
MB.
if you have 500 MB space, okay, you can say process 128 MB. Okay?
Yes. Yes. Yes.
Yes or no? Okay. So this is the need. Okay. Maybe okay. So okay, this is what is the need normally? 128 MB means okay. So
That's fine.
plus 20%. How much it is?
25 approx.
Okay, this is the need. Okay. This is luxury. This is greed. Yes or no? See, okay, to process this data, this is the correct number. Correct requirement is this one. Okay, but okay, but if you feel that okay, fine, 200 MB, okay, it will be very congested JVM. Okay, so let me process my block. Okay, in 500 MB block, JVM. Yes, container. Okay, that's fine. Okay, but 1 GB, 2 GB, and okay, 8 GB and all. Okay, waste, right? Okay, but okay, how do you control? You cannot go and sit with Lakshmi and watch what she is doing. Okay, but can I control Lakshmi? With configuration file, I can control Lakshmi. Okay, so I am telling that okay. So minimum course, I'm telling one. Okay, maximum course I'm telling. Okay, I'm just giving example, guys.
Sir, and what about the resource CPU V cores? This value, what it represents, is maximum, minimum, or what is this, sir?
Wait, sir. Wait, sir. Give some time. I'll explain, sir.
Okay, sir, sure, no problem.
Now you tell me, sir. What I've done here.
We capped Lakshmi, sir. We capped Lakshmi. With
Okay.
minimum and maximum. Yeah.
So now you see here. Okay. So here, okay, I told this property in each and every machine. I told, okay, so minimum course equal to 1, maximum course 2. Minimum MB container size is 400 MB, maximum container size is 4 GB. Okay. Now, if Lakshmi says that okay, my mapper size is okay 1 core and okay 5 GB. Okay, what will happen? Now, resource manager will check what is the size I can give. The maximum size I can give is only 4 GB. Okay, so it means okay, minimum size is 500 MB. Okay, 1 core plus 500 MB. This is the minimum container RM will give. This is the min container. Okay, the max container it can give. Max container is how many cores? 1 core plus 4 GB. This is the maximum container. Okay, so you're restricting. Okay, you're putting some limits to RM. Because who is the one, okay, who is allocating mappers, reducers, application masters? Who is approving? RM only, right? Sir, okay, see, Lakshmi is asking, I want okay, application master of 2 GB 1 core. Okay. Who is giving this 2 GB 1 core application master? end of the RM only. Correct or not?
Yes, sir. Yes, sir.
Okay. So now you are controlling RM that, okay, hey, if anybody asks beyond these numbers, don't give me, don't give. So now if you put a control like this, so that, okay, tomorrow if Lakshmi come and ask, okay, I want, okay, 8 GB RAM container, okay, I want a 1 core 8 GB container. What RM will say, no, madam, okay, no, Lakshmi, madam, you are asking, see, I have some limits to give containers, okay? So maximum container size is 4 GB I can give, okay, as per my configuration, but you are asking 8 GB, I'm sorry, I cannot give you. Understood?
So what if Lakshmi will give the below 500 MB? Is it accept?
Okay, so Lakshmi gives, okay, so I want a container of 200 MB, okay? Then what it will give? What is the minimum container it will give?
1 core.
Huh?
1 core.
500 MB.
500 MB. Minimum allocation is 500 MB. Okay, so if she asks this one, it will give. This is the container it will give.
Okay.
Understood?
It should be between 500 MB to 4 GB only.
Exactly, 500 MB to 4 GB. That's the maximum size you can ask RAM. Cores also 1 to 2 cores. That's it. You cannot ask beyond that.
Okay, sir.
Understood? If you ask beyond that, okay, RM will not give. Will stop there itself. Your job will fail there itself. Understood? Understood? Are any questions? Okay. So now, okay. Now, as per our understanding, okay, where your mapper will run? Your mapper will run inside a container. Yes or no?
Yes, sir.
Yes.
Yes or no? Okay.
Yes, sir.
Your mapper will run inside a container. Okay. So now, minimum maximum container size is this one. Then okay, your mapper size and reducer size should be in this limits only, right?
Yes, correct.
Yes or no?
Exactly.
See, if my container size is 1 GB 1 core, can I run a mapper of, okay, 2 GB 1 core here
No.
inside 1 GB 1 core container?
No.
No. Okay, it means, okay, the mapper size or reducer size should be less than or equal to
Container size.
container size. Okay, it means, okay, so here now you will tell, okay, the mapper size. So, okay, so mapper size also you will tell here. Okay, so somewhere you will tell. Okay, so, okay, what is the map memory? If nobody tell what is the memory, you start with this one. This is what, okay, I'm telling. See, now in the configuration file you are telling that, okay, if nobody tell anything, okay, if Lakshmi did not mention any sizes, then take the mapper of this size. Okay, okay, if Lakshmi did not say anything about the reducer, okay, you take the reducer as this size.
This is default size circuit.
Yes, sir. Understood.
Sir, this default size has given by Apache only, sir.
Yes. Hadoop itself.
Hadoop. Okay.
Understood. Understood. Are any questions, guys?
If more than you want, we need to change the configuration files for you.
Sorry?
If more than requirement is more means we need to change the configuration here. Size.
Sir, Venkat, sir.
Sorry? You understood now this concept?
Controlling is Lakshmi, okay, but if I
Here,
need more,
here only you are controlling everything actually. Okay. See.
maximum.
Okay, in the same way, default mapper size, default reducer size. Okay, and okay, default. Okay. This one application master size also. Understood, sir? Now. What the default size of application master?
1 core 2 GB.
1 core 2 GB.
1 core 2 GB. Default mapper size 1 core 1 GB. Default reducer size
1 core 1.
1 core. Okay. Understood. Understood? Or any questions? Okay. So now this is what I have given, sir. Okay, this is what I have given. Now the question is that this is how I am controlling. This is how I am controlling here. Okay. Now, okay, for this machine, can I do like this, sir? Can I give like this? Hmm?
Yes, sir, we can give it.
But okay, where is 16 GB RAM? You told okay, so from this machine, you take 16 GB. Your share is 16 GB.
Okay,
You are telling
OS.
no. You are telling your Yan, okay, from this machine, from node manager 1, okay, from node manager 1, okay, you take your capacity is 16 GB. But okay, I have only maximum I can take is 8 GB only, right?
Yes, sir, 8 GB, yes. And 2 core also.
8 GB, 2 cores I can take, okay? But can I tell, okay, you take 16 GB here?
No, sir, you can't.
Actually, you should not tell because available is only 8 GB. Yes or no? Okay.
Yes.
But if you tell also, no problem. Okay. Why? Why? Okay. See here, Yan. Okay, you are telling Yan. You are telling Yan that okay. So in each machine, your capacity is okay. In each machine, your capacity. Or shall we go with these numbers only? In that scenario, we will go with these numbers only. Okay, 8 cores. Okay, 1 course. Okay, maximum allocation course only. Okay, 8192. 8192. 1024 is minimum. Okay, maximum 4096. Okay, yeah. We'll go with this number only, sir. Is it fine? You should not tell this one, sir. Okay, so I'm going with this number only. Okay, but okay, here okay, I'm telling that the minimum size is 1024. This is what I'm telling. Okay. Understand, sir? Understand or any question? This is what I'm telling now. This is what I told. Okay, so 6 GB. Okay, sir. Minimum course. Okay. Only 2 cores, right? I should show. But this is the capacity. Okay, but okay, for our understanding purpose, okay, so now what I'm doing, okay, I'm giving like this. Okay? Minimum allocation course 1, maximum allocation course 3. Minimum RAM 1024, maximum RAM this one. Okay. This is what I'm telling. Not this one. This is the one I'm telling like this. This is what I'm telling in each and every machine, sir. Okay, but so as for this one, okay, what it is thinking, what Jan will think, okay, from this machine capacity, my share is 8 cores and 16 GB RAM. But do you have 8 core 16 GB RAM here?
No.
I'm telling that okay, this is your share. Okay, so it means okay, RM will think that okay, in each machine okay, we have 8 cores, 16 GB RAM, 8 core 16 GB, 8 core 16 GB. Understood? Understood? Are any questions?
No, RM will think there are more number of RAM.
Yeah, even though it is not there physically, but RM will think that okay, my capacity is, so they told in the configuration file that my capacity is this much, so I can go up to this one. But if you start really using, okay, do you have so many resources?
No.
No, right? Okay.
So that configuration is faulty, sir.
Sir, actually, in real time, you should not put this kind of configuration. So whatever is available, you should put that much only. Understood?
Okay.
Understood.
So RM will follow the configuration for blindly.
Yes, RM will follow the configuration blindly.
But this
So
will
there is a possibility of failure more frequently.
Of course, yes. Okay, if you try to run multiple JVMs, okay, then okay, RM will think that I have this capacity, but it is not actually. It is not there. Okay, so anyway, for practice purpose, in real time, you should not do like this. Whatever is available here, okay, only that much you should put here. Understood? Understood?
Yes,
But
sir.
okay, our practice purpose, okay, I'm doing it like this. Okay. So now this is done. These are the properties I have put. Okay. Again, okay, so I'm opening mar24 XML. This is also another XML. So here we'll copy these things. Now there is something called validate XML. Okay, let's go for that actually. Better to have. Otherwise, you guys will enter whatever you want and okay, say that okay, it is failed, sir. Failing, sir. Validate the XML. After doing every change in the configuration file, let's validate the XML files.
Sir, in real time, the node managers will be there in the same place, sir. Data node.
Yes. XML is valid here. Okay. Yeah, both are valid. Now you put the modified configuration to another version. Okay. 3 and 1. Okay. Now I'm starting the services, guys. about this job history server. Okay, wherever RM is, I told you I'm starting resource manager. Wherever I started data nodes. Okay, I'm starting node manager there. Okay, in each data node group. Okay, okay, in the data node group, I'm starting node manager here. This is the job history server. I'm starting and services. I made the changes. Now I'm starting the yarn services. Okay, once done, okay, now you see the clash. Okay, now wherever name node is running, okay, so here, okay, resource manager is running. Yes or no? Huh? Okay, now wherever data node is running, node manager is running. Data node, node manager. Okay, data node, node manager. Okay, clear or not? Okay, now is it like this or not now? Is it like this or not?
Yes, sir. Wherever data nodes are running, node manager.
So now I have one RM node managers. Yes or no? Okay. Now let us open RM UI. Let us open RM UI. RM UI. Where is this RM UI? Okay, resource manager UI. Okay, so it is running on 181 machine and 0088 port number. Okay, this is the RM UI. It is completely empty. Okay, so now you see here. Click on nodes. Okay, what it is showing nodes, guys? What it is showing nodes?
Racks.
Racks, rack 1, rack 2.
So rack 1, rack 2, it is showing. Okay, so then okay, what else it is showing? S3, N3, S3, N4, what S3, N5? What is the status? All are running. Okay, then okay, I told okay, user memory, available memory. Okay, what is the free memory here? Available memory. I told like a maximum 16 GB, right? 16 GB, 16 cores in each machine. 16 GB, 16 cores. Okay, so now it is thinking that okay, this machine is having 16 GB RAM and 16 cores. This machine is having 16 GB RAM, 16 cores. Okay, so this is what I mentioned in the yarn configuration file, sir. This is what I told. Okay? 16 cores, 16 GB RAM. This is what I told in the configuration file. And every machine configuration file. This is the reason. Okay, each node manager is thinking that okay, my share okay from this machine is 16 GB, 16 cores. This machine also telling that okay, my share from this machine is 16 GB, 16 cores. Okay, my share from this machine is 16 GB, 16 cores. Okay. Now overall, okay, what is the memory total? Sum of all these things. 316s, 48 GB. Okay. Overall cores, 316s, 48 cores. Understood? Okay. This is called cluster state store. I told right. Okay. So as and when you start your resource manager and node managers, immediately, okay, resource manager will send heartbeat. Sorry, node manager will send heartbeat, right? So I told cluster state store. It is running, and okay, what are the resources? Okay, this is the table. Okay, I'm showing you now. This is the table. Okay, but where is application state store? Okay. If you click on applications, then it will show you application state. Do you have any applications here, guys?
No.
Do you have any applications here?
No, sir, empty.
Okay, so no applications at all, completely empty because we are not running any jobs till now. Okay, so now what I can do, so to maintain log aggregation, okay, so I need to create some directories here. What I will do, I will create a directory here. To look into this issue, why it is.
Venkat, while doing this configuration changes, is it recommended that we will do stop? Means stop. We will stop services and start services in single go, or in rolling fashion also we can do.
Rolling fashion, sir. Rolling fashion.
Okay. So
okay.
Once we did H3N1, then we can push that file to everything. Then we can, in rolling fashion, we can restart everything, every node and daemon, correct?
Yes, sir.
Okay, sir. Got it. Yeah. Thank you.
Okay. So now I started the resource manager, one resource manager, 3 node managers, and okay, each node manager is sending heartbeat, and each node manager is telling that okay, I have 16 cores with me, 16 GB RAM. I have 16 cores, 16 GB, 16 cores, 16 GB RAM. Okay. So now, okay, shall we test one? Shall we run a job and a test, guys? Shall we run a program? Huh?
Yes, sir.
Shall we run a program? Okay. So now who will write the program? We are admins, right? Do you know how to write a program?
No.
Hadoop program? You don't know, right? Okay. So that is the reason. Okay. So by default, Hadoop is giving one example stud jar, sample stud jar. This is the location. Okay, you will have. So this is the location. Okay, you will have. This is the location where you will have jar file. Okay. Now you see. Okay, this is the jar file. Okay, inside this jar file, they are giving so many programs. Using this jar file, it is not one program. Inside this jar file, there are so many programs. Okay, understand? Normally, this jar file contains. Okay, normally when somebody write a program, okay, let's say this is the jar file. Okay. So this is the jar file they have written. Okay. Normally, how they write the program? Okay, so let's say they have something called word count jar. So if they write this program, this jar will have total 4 classes. One is main class. Understand? One is main class. Okay. Other one is okay, mapper class. Okay. Other one is okay, reducer class. Okay. Other one is top class. Understood, sir? How many classes each jar will have? It means okay, if a developer write a program, okay, and if the program name is word count jar, that jar will contain total 4 classes. Understood? Understood or any questions?
Understood, sir.
Understood, sir.
Okay, so these are the okay. It means okay. Now we have a jar file. Inside this one, do you think all these 4 are available or not?
Yes.
Since it is sample, all should be available, I believe.
Okay, so this is example jar means okay. So this will have all these 4 classes for sure. There is no doubt. Okay. So now what I'm doing. Okay, so here, if you see this one, okay. So it is saying that okay, I can run all these programs for you. Okay, but there are many programs. Okay, but okay, let us do one thing. Okay, let us run this program, word count program. Understand? Huh? Let us run word count program. Okay, so now, okay, here paste and give the word count. What are you giving here, guys? Yan. So the command is starting with yan. Yan jar. Okay, yan is the command. Okay. So what are you passing here? Jar file. What is the jar? This is the jar file. Okay. And inside this jar, okay, which program I need to use? Word count. Okay. Press enter. When you press enter, what it is saying? Okay. What is the usage? You should give input file and output file. Understood? Okay. But are you giving input file? You just told what is the class name, what is the program name. So what is the jar name and what is the program name? Okay. But you have not given the input. Okay. So first, okay, if you want to run any distributed, uh, if you want to do distributed processing, my data should be in distributed storage. Yes or no? Okay. Now, where is the data here? So now, let us do one thing. Okay. Let us run this program by step. Because Alan is having okay, TFS-ls project DLR. Okay, so there are 2 files, sample1.txt and sample2.txt. Correct or not? Okay, so now I'll select SDFS DFS set rep. One second, guys. Okay. Sorry. Okay. Let's not waste the time, guys. Okay, so now we have two files, project BLR. Okay. So there is a file. Okay, so now if you see, there is something. Okay, so here, so there is a file which is sample.txt. Okay, which is an alien name. Okay. So now, what we will do? Let us execute a program. Okay. So now here, what I'm telling, try to understand this. Okay. So now I'm running a command. Word count. Okay. This is the command I'm giving. This is the command I'm giving. The command. Yan jar
లైన్ మొత్తాన్ని బిడ్డలు లేదు అల్లరి
yan jar. Okay. So this is the program here. What I want to execute. Okay. And here is the sample.txt. Okay. Here is the sample1.txt. This is the input file. Okay. Now project BLR. Okay. Where you want to where are you expecting your output? Okay. I'm expecting my output on this folder. I want to save my output in this path. Okay. So now, let us see the cluster also here. Okay. So let us see the cluster also here. This is the cluster. This is the cluster. Okay. Now, in which machine we have this 5 blocks. We'll see this one also. Okay. SDFS, FSCK. Okay. Hyphen files, hyphen blocks, hyphen racks, hyphen locations. Okay. So how many blocks it has, guys? What is the size of this file? Sample.txt file. Size of the file is this one. 250 MB. Okay. It is divided into how many blocks? It is divided into 2 blocks. Block 1.
Two blocks.
Where is this block 1? I'll set a replication right 1, right? We'll see. Okay. How many blocks we have here, guys? Okay, we have 2 blocks. So this is the block 1, half size 128 MB. Okay, this is the block 2 of 122 MB. Okay, and where is block 1? Block 1 is in 185 machine. 185 machine. 185 means a quick machine. This is 185 machine. This here is the block 1. Okay, and where is block 2? Block 2 is in 180. Okay, so block 2 also in 180 machine, 182 machine. Okay, so unfortunately both the blocks in the same machine. Yes or no? Do you agree with me, guys? Okay, this is my cluster. Okay, this is my cluster. Okay, now okay, I have a file which is of 250 MB file. Okay, and okay, this is the block 1, block 2. So block 1 of so 128 MB. So block 2 of 122 MB. So this is clear. Now I'm running a command. This is the command, guys. Is it fine? Okay. So now press enter. Now you type JPS. What has started? Okay. On Edge-Node, I executed the command. So on Edge-Node, okay, Ranger has started. Okay. What Ranger has done? Ranger has sent the request to resource manager. Yes or no? Now you see, it has sent the request to resource manager. Okay. Now, what resource manager has given? Okay, so resource manager has given one ID for you. Okay, so it is telling that okay, hey Alan, thanks for submitting your job. Okay, this is your job reference number, which is nothing but your job ID. Okay, which is your job ID. Okay, now is it working or not? So map 100% completed now. Okay, now it is starting the reducer work. Reducer also 100% completed. So finally, it has saying that okay, completed this job successfully. Okay, so what has been done? Okay, so this is what has happened. Application master. Okay, so Windows man has given this number. Okay, now so where is the output? What is the output location I have given? What is the output location I have given?
Project PLN.
Output. Okay, so now let us go and insert this one. What is the insert this one? So do you have the output file? There is one success file. It means okay, this success file will be created only if your job is successfully completed. Okay, but anyway, this is 0 size file. Okay, nothing to worry. Okay, so now there is another file which is part R. Okay, can I cat this one? SDFS DFS hyphen cat. So now it counted all the words. Okay, it is telling that okay, Apache word repeated okay 8,55,000 times. Hadoop word repeated 8,55,000 times. Okay, it repeated these many times. A repeated these many times. Okay, and repeated these many times in this file. Which file? In the input file. What is that input file? Sample1.txt. Correct or not?
Yes.
Is it counting each and every word or not?
Yes.
Huh? It is counting each and every word. Understood? Are any questions?
So the output folder is created default or
No,
will
you
be
don't need
created?
to create. Okay, Hadoop itself will create the output folder and store this your output into that file.
If you run the another job, it will store in the same folder, sir.
No. Okay, you should give another output directory. Understood?
That means we have to create that output folder.
Sir, okay, you need to tell what is the output directory. But okay, if you tell that, you need to tell, okay, Hadoop will create the directory and store your output there. If the same output directory is already existing, suppose, okay, now, if I give the same command again, what will happen? You think? Now I'm giving the same command again. What Hadoop is saying?
It's already existed. I think.
It is telling that, hey, output directory is already existing.
So then what you have to do now, sir?
Sorry?
Now what
So
we have to do?
you give the different directory. So you give output 1. Then second program output will be written in the output 1 directory. Understood?
So like this, how many jobs you are submitting? That
If
many.
you run 1 lakh jobs, okay, you give 1 lakh. You have to give 1 lakh paths.
Okay, sir. And one more thing, sir. You run a command like skip trash. What it is, sir?
Skip trash means, okay, without moving to trash, okay, it will delete the file.
The skip trash trash also default is there, sir.
Default is there, right? Yeah.
Yes, sir. Yes, sir. Thank you.
Okay, sir. Okay. So, okay, you got the output now. Okay, but you got the output. Okay, so and you are able to see the output now. Okay, but okay, see, we are almost time up now. Okay, I cannot explain also. Okay, and I cannot show internally how it is working and all. Okay, we'll continue in the next class. Okay, guys, tomorrow I have okay one executive committee offset meeting tomorrow for me. Okay, understand? So and okay, I need to be there in that location by 9 a.m. Okay, and okay, the offset program will go from morning 9 to evening 5:30. Okay, so that's the reason. Okay, I may not be able to take class tomorrow. Okay, and last week also, okay, for Friday, okay, we missed one class for Holi. Okay, and okay, tomorrow also we are going to miss one class. Okay, I don't want to take 1 hour class tomorrow. Okay, because I need to get ready and go. Okay, so that's the reason. Okay, let's cancel tomorrow's class. Okay, but okay, I have 2 pending classes. Okay, when can I cover these 2 pending classes? I want to cover this weekend. Okay, so what I will do? So anyway, okay, Saturday morning, okay, as usual class, right? Okay. 6:50 a.m. as usual, we have a class. No? Okay. So let's take Sunday 6:50 a.m. also, okay? And Saturday, okay, 6 p.m. class also. Then Saturday you have 2 classes. One is in the morning and one is in the evening. Understood? And Sunday you have morning class. So that okay, we can cover the missing classes. Otherwise, okay, we are running okay, very slow here. Understood? Maybe you cannot. Many people are replying to my questions. That is the reason. Okay, maybe I am trying to explain more and more. Okay. Because of that, okay, please cooperate for the missing classes. I'm not asking you extra time. Okay, I'm asking for the missing classes. Okay. So this is the plan. No change in the plan at this moment. Okay. So tomorrow no class, and okay, the same class will be covered on Sunday morning, and okay, previous holy holiday class will be covered on Saturday evening at 6 o'clock, 6 to 8. Okay. So that's the plan, guys. And thank you so much. And okay, see you all on Saturday.
Thanks.
Okay, sir. Thank you.
Thank you, sir.